In this video we are going to look at another product of vectors, the cross product, where you take two vectors, multiply them with this cross product, and you get a third vector as the result. So the way it works, if you have two vectors with components, so vector A with components A1, A2 and A3, and vector B with components B1, B2 and B3, the cross product of A and B is going to give you a third vector which is perpendicular to both A and B and has certain other properties. So let me just give you the formula, the way to compute this cross product, which is denoted by this cross A cross B. For vectors, these components, it's easiest to remember how the cross product is computed using a 3x3 determinant, where you put the basis vectors I, j and k in the first row, you put the first vector's components in the second row and the second vector's components in the third row of the determinant, and then you simply evaluate this determinant so to get the linear combination of I, j and k and the components of the cross product. So if you do that, you might recall that a 3x3 determinant can be written as the sum of 2x2 determinants, and that's what I'll do here first. So if you expand the determinant by the first row, what you get is a 2x2 determinant that is A2, A3, B2, B3 multiplied by the vector I. Then with a minus sign you get the next determinant that is obtained by covering up the row and column of J. So that's A1, A3, B1 and B3. That's multiplying J, and with the final plus sign, the determinant multiplying the vector K is that 2x2 determinant, which is A1, A2, B1, B2. So that's a way to compute the cross product. Of course, these 2x2 determinants themselves can be evaluated or computed by basically just taking the product of the diagonal elements and subtracting the product of the off-diagonal elements. So this is why we get A2 B3 minus A3 B2 times I minus A1 B3 minus A3 B1 times J plus A1 B2 minus A2 B1 times K. So this is the expansion of the cross product in the spaces I, j and k, and of course in terms of components one could just collect these components on the right, A2 B3 minus A3 B2, A3 B1 minus A1 B3 and A1 B2 minus A2 B1 for the three components of the cross product. So it's a complicated looking formula, but it really is as simple as just remembering how to evaluate a 3x3 determinant, and the rest is an easy consequence of that. So as I said, this cross product is a vector which is perpendicular to both of the vectors that were used to create it, and the extra property or a feature of this cross product is that its length is in fact the length of A multiplied by the length of b and multiplied by the sine of the angle between those two vectors. So remember again, if I have a and b as these vectors and the angle between them is theta, then this is the length of the cross product. So the cross product, of course, will be perpendicular to both of these vectors. So a cross b would be something like this, perpendicular to those two vectors, and its length is given by this formula. And in fact, if you look at this formula, you might realize that this, what you have on the right hand side, is exactly the area of this parallelogram. So this is the area, okay, and it's the area of that parallelogram. That is the sine area of that parallelogram. So with that, let me give you my first question. Question 1. Explain or show why for any three-dimensional vector a cross a is the zero vector. Okay, so pause the video and try to explain and show why that is true. Okay, I hope you paused it. Well, the easiest way to see that is just simply looking at this length formula that we have there. Of course, you have the length of a multiplied by itself, so squared, but then the sine of the angle is now the sine of 0, because a vector makes an angle that is with itself that is 0, so the sine of 0 is of course 0, so you get 0 for the length of the cross product of a with itself, and as a consequence of that, a cross a is 0, is the 0 vector. Okay, so that was the first question. My second question is, take 3 points in 3D space. So point P should be 1, 4, 6. Point Q has coordinates -2, 5, and -1. And point R has coordinates 1, -1, and 1. And so my question is, what is the cross product of PQ, of the vector PQ, with the vector PR? Okay, first, of course, you have to compute these vectors and then their cross product. So pause the video and input your answer below. Okay, so I hope you paused the video and first of all computed these vectors PQ and PR. Let's just do that quickly. So PQ will have components that is -3, 1, and -7. All I did was computed the differences of coordinates. Now for PR I have to do the same thing for P and R. So 1 - 1 is 0, -1 - 4 is -5, and 1 - 6 is also -5. So with these components, now I can go ahead and simply compute the cross product, the components of the cross product. So if I do that, I will get, for the first component, I will get 1 times -5, that's -5, minus -5 times -7, so that's plus 35, which is getting subtracted. So for the second component, I will have -7 times 0, that's 0, minus 3 times -5, that's 15, so 15 is getting subtracted. And then for the third component, I have -3 times -5, giving me plus 15, and I have to subtract 1 times 0, well, that's just 0. So all I get for this is -40 minus 15 and plus 15 for the three components of this cross product. Okay, so I hope you got it right. And now for my third question, I would like to ask you to, well, let me just see. So the third question, what is the area of the triangle that I get by connecting these 3 points? So P, Q, R, when connected, form a triangle in 3D space, and I'm asking for the area of that triangle. Okay, pause the video and input your answer below. Okay, I hope you paused it and realized that if you have these 3 points P, Q and R connected to form a triangle, it's like taking PQ and PR. So let's say these are P, Q and R. So this vector A is the vector PQ and the vector B would be the vector PR. So, and we are interested in this triangle, which is exactly half of the size of an area of that parallelogram, whose area is given by this formula, which is the length of the cross product. So all we have to do is take this cross product and compute its length and divide by 2. So it's half the length of the cross product of PQ and PR. Okay, so let's compute the length of that vector with these components. So that's minus 40 squared minus 15 squared and 15 squared. Okay, so let's see. Okay, so what we are getting here is what we are getting here is 1.5 times, well, under the square root we have 1600 plus this one is 225 plus 225. Sorry, that's not correct. Where is it? Yeah, it's correct. Okay, so this is 450. So this area is root 2050 divided by 2. Well, one could simplify. For example, this is 25, a multiple of 25, and it's exactly 82 times 25. So the square root of 25 is 5. So this is 5 over 2 times root 82. So that can be the final answer. Okay, I hope you enjoyed this video and I'll see you in the next one.